Alankar sir, thank you so much for doing this. Welcome to the call. And
Is-
so we'll talk about DevOps overview now. Over to you, sir. Thank you.
yes. Is my screen visible?
Yes.
Okay. I'll start with like who am I? So I'm Alankar. I have 5 years of working experience as a DevOps engineer. I am currently working at IDG Cloud Technologies as a DevOps engineer from last 3 years. I mostly expertise in orchestration and monitoring and observability, and I keep myself updated with Linux ecosystem. So that is really important if you want to get into DevOps. So you need to start with Linux, and first thing would be like, what is DevOps? So I would say, so it is actually a really broad term. So there's no a proper definition, I would say. Uh, each organization has its different DevOps environment, what they do. But what I think is what is actually a DevOps. So a DevOps engineer would be who thinks like a DevOps person, and an operational engineer who would think like a development person. So as a development person, you would need to understand how the application is working, how it is configured, how it behaves in real world environment, how to monitor it. And from operations person, you would need to understand like what kind of infrastructure it would need, what kind of automation it needs, and how it would behave on your any kind of environment. And so you need to have like understanding of both development side and the infrastructure side to share responsibility, and you need to actually work together with the development person and understanding like how his application is going to behave, how it is configured, and all the insights and out. So that is actually important. Without it, you would if you would deploy the application, you would not understand like what is happening, where is the what the application is trying to do and why it is failing. So it's really important to collaborate with developers and understand the application. Okay. So any questions on this?
Alankar sir, I suggest that we take the questions later on. We could
Okay,
continue.
sure.
Yeah.
So, like I said, there is no proper definition for DevOps. So every organization does DevOps differently. Some would only use DevOps in monitoring and observability. Some would only use in deployment. Some would only use in the infrastructure part. So it's a really broad spectrum of things bunched together. You can be a observability engineer and still doing DevOps. You can be an SRE engineer and still be doing DevOps. You can be a platform engineer and still be doing DevOps. So there are a lot of things that comes under it. So it's hard to define it in a single definition. So these are mostly what are the roles and responsibilities of a DevOps engineer. So from the very first and the simple thing is is the CI/CD management. So you have to automate your automate all the stuff, like in there should not be any manual intervention at any point. So whenever something you have to make a change, it should be automated. You have to have cloud management expertise, so like Azure, AWS, even on premise or hybrid. So this is like your organization requirement, how you would manage the cloud and which cloud would be managed. And dependent on that is the infrastructure as code and automation. So you need to have all your infrastructure written in a code format. So you would have the reproducibility, and you can clone it properly. And after that you come to observability and monitoring. So you need to know like what is happening in your infrastructure, in your application. How is everything behaving? What is the health of your infrastructure, your application, your clusters? So for that you would need observability and monitoring. Containerization, again, containerization is really it is the main one of the main important and main things of DevOps. So you have to learn containerization. So we will look into it in the next slide. So dependent on that is orchestration. So how would you orchestrate hundreds of containers? So we would also see in this in the coming slides. And yeah, another is the collaboration for troubleshooting. So as I said previously, you need to work with the development team and understand how the application works, how the application behaves. So for that you need to collaborate with the development team and resolve the issues in production and really quickly. So CI/CD stands for continuous integration and continuous development. So you need to have a source control, Git for it, and where all your developers will commit their code and push the code. So uh, so that would be your continuous integration part, that everyone is continuously updating the code and changes are happening. And continuous deployment would go into your deployment pipeline. So this is a simple pipeline uh, diagram I have given. So it starts from your Git repository, and as soon as the code is merged, an automated trigger is pulled that would execute the pipeline. So it will fetch your code from Git, it will compile, it will package, and it will deploy. So this is a really simple diagram showing what actually goes on in your CI/CD pipeline. So you can actually take it really further and do lot of things with it. So it is not only limited to just compiling and deploying the code. You can do various things in CI/CD pipeline. You can run cron jobs. You can trigger things. You can even do infrastructure changes with CI/CD. So there are a lot of things you can accomplish with your CI/CD. You can release your software you can with CI/CD. And yeah, so these are like uh, the things you can do. Just an idea about what you can do with CI/CD pipelines. And so there are also tens of tools to do CI/CD with. So you have the Jenkins, which is really the industry standard. So if you want to get into DevOps, So I would suggest that you should start learning Jenkins, and with that you can actually you can crack any interview that because the Jenkins is it is a base. So if you know Jenkins, you can move over to GitHub Action or GitLab CI. So after that, everything is easier, I would say. Jenkins is much more complex, so but you have to have knowledge about that. So once you do Jenkins, then GitHub Action, GitLab CI or Travis CI or Argo CD, any of these tools would be really you would feel really easy. And one more thing is that you have to have some coding knowledge. So there is it's not that you would need coding, so you need to have some basic understanding how the syntax works. uh, so Jenkins would use Groovy languages, so it's a Java based language. So you need to have some background in coding. I would say preferably Python, because it would help you in automation. Okay, so next slide is automation. So automation would again automation tools will also depend upon your organization. So some would Python and shell scripting is like the important things. You would need Python scripting and shell. And if your organization uses Windows based system, then you would also need PowerShell understanding. And apart from that, you would need it would depend on the organization, and what kind of task you want to perform. So the language would depend on that. Nowadays people are actually going with Go and Lua for automation also. So if it would be really helpful if you learn any programming languages. So start with Python, and then shell scripting, PowerShell if you need. And if you do Python and shell, then any other languages would be really easier to understand and quickly start working on it. Like what you do with automation are various things. Like the basic things, like you can trigger something, like you can schedule something, like you have cron jobs, you can set a cron job in your pipeline. So you can say, like if I want to take a backup of something, like my database, I can write a Python script in my pipeline, and schedule the job to run for like 12 a.m at night. And my Python script will run, and would take a database backup from the my database, and it will upload it on the in any storage system, like maybe S3. You can do that. You can also if you want to have restart your infrastructure, you can do that. You can create infrastructure at certain point of time or destroy. Like you at night, you don't need your infrastructure, right? You don't have that kind of traffic. So maybe at night you would want to lower the uh, uh, scale your infrastructure to minimum size. So in that case, you can also use automation script to scale it down. And you can also again restart services, configure cleanup jobs on your system. So you can also do that. You can also configure scraping jobs, like you want to get how much like how much resources are consuming. You want to scrape that data and put it in a file, and read it on your monitoring dashboard. So you can also do that. So you have to have these things set up automated way. You should not be doing anything. You should not be putting any manual efforts to start something or trigger something. So everything would need to be in automation format, so it would make your life easier. So from that, infrastructure as a code, you need to learn, like, again, a programming language would really help you understand how to write a script for Terraform or Cloud Formation or Pulumi or Ansible, Chef, Puppet. So you have to understand, like, any of the programming languages. Terraform uses its own HashiCorp languages. Pulumi has a support for multiple languages. Cloud Formation has its own set of languages. So you need to understand that. And with, like, infrastructure as a code, you need it to set up your infrastructure. Yeah, sorry. So Terraform, infrastructure as a code is needed for you to create your infrastructure in a declarative format. So you would know, like, so there should be no click ops again. You should not be going through the dashboard and clicking on things and creating resources. Whatever you do, it should be documented in a code. It should be other people should be able to collaborate in it and understand, like, how everything is configured. So for that purposes, you need to have infrastructure as code. You would also require it to create identical resources if you need. And you would also changes, you can do changes really quickly. uh, for that, you would require, like, Terraform or and like similar tools. For uh, so for uh, Terraform, it would be like creating an infrastructure, and configuration tool would, like, configuring the infrastructures. For example, you would create a server using Terraform, but if you want to install something in it, then you would need Ansible or Chef or Puppet, any similar tools. So and uh, again, the different use would another use would be, like, you have hundreds of tens of server once you have created, but you need to update the servers. So if you go with the manual approach, you will have to go in each of the server and update a specific software. So with use of configuration tools like Ansible, you can update uh, all those hundreds of server with one script. So, and that for that, you would need Ansible, Chef, or Puppet, any kind of configuration tools. So again, Terraform would be your infrastructure creating, and Ansible would be your configuring your infrastructure. So one of the important things right now in today's days, if you want to get in DevOps, you have to learn Terraform. So everything, your infrastructure would start from Terraform. And nowadays, actually, Terraform is adding so much support for so many things. It is adding support for Kubernetes. It is adding support for Docker. So mm, uh, it might be that you would not need to learn Ansible, but you would need to learn Terraform. So you can even do configuration things from Terraform side. So it is, really fast growing, Terraform. And if you give any Terraform DevOps interview, they will ask you about Terraform. Like, uh, it's now became the gold standard, actually, for infrastructure as a whole.
One thing here, the spelling of chef is Chief. I think that needs to be corrected.
Yeah, sorry about that.
Sure.
Yeah, so so this is actually, I think, many people miss, and it is actually a really important, part of DevOps. So once your application is deployed, your job is not done. You need to make sure that the environment is healthy, it is running properly, and for that we would need to have monitoring and observability. So without it, your environment would be like a black box. You would not understand like what is happening, how many requests are failing, how much load is there, how much traffic is there, how much what is your infrastructure health, like how much resource your applications are consuming. So you can configure n numbers of things with a monitoring and observability. You can even add custom metrics. So if you want to have like a dashboard, like how many orders I have got today in my website, you can even generate that data and push into your observability stack. So you can extend it to many ways, and you can do it with tools like Grafana, Datadog, Ignos, or Elastic Stack. So these are like the front end of what front end for all the data you have to visualize. So these tools are for that. From that, you then come to like databases. So you have your Prometheus databases that would store the time series data, time series data or matrix, like and mm, yeah. So Prometheus, you need that. And one thing is that you have to learn the Prometheus query languages. So like it's like a SQL language, but you, to visualize, to create dashboards, you have to learn Prometheus language. So again, it is again a gold standard, Prometheus. So all the organization use it. Then again, your log aggregation database. So it is actually depends again on your organization. There are many. There is Loki, there is Fluentblade, there's Logd, and etc. etc. So again, a log aggregation again uses LogQL, again a query, log specific query languages. So yeah, you would have to also learn that telemetry corrector. So these are actually optional, but these are really helpful. So telemetry collection would actually collect to the data, like how your application is communicating, how is your application behaving, what is how many requests has been received. So again, this is an extendable part, so you can extend it from however you like, how you can forward the data, uh, uh, like whatever data you want to capture in it. So you can use telemetry for that. Dashboards, so you have to create dashboards visualization to visualize what is your state of your infrastructure, and like how much load is there. So it would have really helpful if if I had something to show, so you would have understand like how all these things tie up together. So but right now I do not have that dashboard or any databases setup or data source setup. So maybe in coming lectures we can deep dive into this and understand how everything connects and fits in the bigger picture. So again, alert. So alert is your like if you want to set like you want to, your application is behaving like it is down, you can have an alert setup, like my XYZ application is down. You can even set an alert to like how many requests are failing. Like if 5% of your request is failing, then you can also get an alert on that. You can also get an alert if if there is a high load on your infrastructure. So you can also you can get alert also. So you can actually set an alert on anything, but the important part is you don't need to set alert on everything. So if you create too many alerts, you get too many noise. You won't know which one to fix, or which issue is actually a self-healing issue. So you have to be careful on the alert part, not to overdo it. Yeah. So let's move on next. So yeah. So containerization. So what is actually a containerization? Uh, so so this gets in, this problem happens every time that my it works on my machine, and it does not work on the cloud environment. So this is the problem that containerization tries to solve. So in containerization, you basically package your application, and then you can run it anywhere. So once you have a Docker, you have Dockerized your application, so you can then run it in anywhere, uh, and make it portable, and it would run in any environment. It would not, you would not do not need to rebuild it, and you can run it on your machine, your colleague's machine, or any cloud environment. So it is actually portable and a simplified version of your application. And so in that way you can, run it anywhere. So for that, we mostly use Docker. So 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 it has now become a really important tool. You would actually create a Docker file, and you then package your application with that Docker file. So from your code, from your artifact like Java jar, or even Python code. So once you create a Docker image with that, you can run it anywhere. So it is like you just once build it, and then you can use it anywhere. So your problem is really solved. So it is like a virtual machine, but it is a Linux, like a really kernel based what kernel based virtual machine. But just it does not run directly on your system, so it is not as resource hungry as a virtual machine. uh, so you have your environment consistency with that. So you can just promote your Docker image to another environment, and it is easy, it is lightweight, it is, comes in solves so many problems in your environment. So now imagine if you have hundreds of microservices running in a container. Now the problem arises that you have to manage these services individually. That can be really painful. So you have hundreds of container, one of them fails, you have to manage it separately, you have to inspect it separately. So in that case it becomes a really complex task to handle all these containers. And this is where actually Kubernetes comes in. It is a container orchestration tool that would help you to deploy, manage, scale, and monitor your containers automatically. And you can even configure how your application should be run, and so many things you can do with Kubernetes. It can scale your containers. It can auto heal them. If your deployment fail, it can even take care of your failed deployment. Uh, you can uh, you can do like load balance it, create so many replicas. So you can with Kubernetes you can do that. So that is the problem that Kubernetes solves when you have hundreds of containers or even 50s or tens of containers. So Kubernetes actually is a really complex tool. So you can do so many things. You can scale your cluster. You can increase the instances of your application. You can update deploy. You can employ deployment strategies from directly from Kubernetes. You can have your declarative configuration with Kubernetes. You can set how much resource you want to provide to each of your microservices. So you can even set up your own Kubernetes with different set of tools that you want to use. So you can even configure what networking fabric you want to use, what how the architecture you want. So if you set up metal based Kubernetes, you can control so many things. And you can even create custom resources in Kubernetes. So if you want uh, something you want to do execute, or something you want to create custom Kubernetes feature, you can do with CRDs. So you also get a feature for that. And so administrating Kubernetes is also is a complex task. As I said, you have to create so many, uh, you know, uh, manual. At low level, you have to set so many things like permissions. You have to set storages. You have to set networkings. You have to set your extension. So there are so many things, so many things you can do with Kubernetes. And nowadays, everyone wants to orchestrate with Kubernetes, and it is also a really important skill that DevOps engineer should know. And yeah, so that is all about Kubernetes from my end and DevOps. So anyone has any questions?
This was very, very informative. Thank you.
Thank Yeah, thank you.
Yeah. Are there any questions? Otherwise, I have some questions. So my first question is how exactly Gen AI is affecting this domain?
Yes. So again, Gen AI would. Uh, so nowadays, actually, there are two things with Gen AI. In interviews, you would be asked like, how are you are utilizing an AI into your workflow. So you have to integrate how would you use and build things faster with AI. Another would be like how you are exactly deploying your AI, or managing ML AI life cycle. So this would come in your continuous integration and continuous deployment. So again, it would start with your Git and similar tools. So with Git, it comes with your also data warehouses you have to configure. So instead of compiling, you would run the training, and instead of packaging, you would store the ML model. So these two steps are also you have to work with Gen AI. AI tools or AI framework. So there are many, like Kubeflow, you can use it to handle these life cycle, and ML Flow you can use it for handle the life cycle, or you can use AWS SageMaker to handle the life cycle. So yeah, you can utilize these tools.
Thank you, Alankar. One more question. How exactly security is taken care during in DevOps, DevSecOps?
Yes, so security, like you have to configure network security at the first. So your communication should be encrypted with, even if you are communicating with two of the microservices. In that case, your communication should be encrypted. Like your database communication should also be encrypted, so you have to configure that. Like your secret management, that is also uh, you have to take care of with external services like HashiCorp Vault or AWS Secret Manager. So security part, you have to look into that. And even from Kubernetes part, you have to configure these particular services as agent in your Kubernetes cluster. So the secrets would not be used, and they should not be secret externally accessible.
So I've
Yes.
heard that there is in GitHub Actions there is something about security that we can define. Just a few lines of code and your entire stack that would be getting deployed. Before it gets deployed, the security is kind of checked, and even after it is getting it has got deployed, the tools are there to check the network security, application security, or the infrastructure specific, the configuration specific. The checks are also can also be added within your CI/CD pipeline itself. Uh,
Yes, yes, yes. Similar things are also available in GitLab.
okay,
So in GitLab, it is called Auto DevOps feature. So
okay,
yeah.
okay. Any other questions from anyone? Okay, how much is the difference between AI as in DevOps that we do for any of the full stack or distributed applications and the MLOps? What components really get added to the base DevOps tools and frameworks and process?
Yeah, so that would actually be really different from a full stack application or any uh, backend front end application. So instead of compiling, packaging, uh, you have to use an external framework, like I said, Kubeflow or any ML Flow framework for Amazon SageMaker. So once your pipeline is triggered, it would in then it would in after that it would actually trigger the ML Flow workflow. So you have to write scripts in your repository for how the flow would be executed. So it would actually the flow would be executed in your ML flow or external application. So and then it would then keep track of how your AI training is happening, what is the version of the last run set, and like how your training results are. So everything is stored in that external application.
Okay.
Yeah, even you can even take it further and configure your application, your backend application that will access that trained model. So you can even go and configure your application to be notified that a new version of model is deployed, and you can update the model version.
Okay. Sure. Any other questions from anyone?
No, nothing from my side.
Alankar sir, once again, thank you so much. Do you have anything else to present, or
No, right now I do not have anything else.
this was very, very informative? Alankar sir, thank you so much for doing this. Uh,
Alankar sir, one question from my side. Just wanted to understand, like, I'm from testing background or anything. So anyone want to excel in DevOps, being in testing. So in which role you can get into? So you mentioned many roles like CI/CD, automation, cloud management, orchestration, and all.
Yes.
So wherein tester or QA can get into that, and what's the syllabus? Do you have anything to guide us?
Yes, so if you like start with CI/CD, this is really the simple and most important thing. You start with CI/CD, you start with automation, and you start with cloud management. So these three are really the basic. So once you start with these, you then gradually you can uh, get start learning other things. So
So first three you
start
say
with
is the basic one. Yeah.
yes, CI/CD
And
and scripting, automation scripting.
automation scripting. And within that, any specific scripting language or some?
Yeah. So CI/CD is actually dependent on the tool. So what tool you would use, language depend on that. Mostly nowadays, YAML syntax is used, and for automating, just Python and Shell.
Python and Shell. Python and Shell or
Yes.
Python or Shell?
No, no, both of them Shell, Python and Shell.
And any website or any syllabus where sequence of tutorials are there or something, then you can I can start with or someone can start with. Any suggestion on that?
Uh, sure. I right now do not have any written notes. Written links. But sure, if
You
once
can help
I
us on that, right?
yes, yes,
Yeah, that is sufficient. Thank you. I will connect you in offline.
yes, sure.
Thank you, sir.
One of the very important aspects is Git commands, merge, Git merge, Git pull.
Yes,
Something that is
yes, yes.
also very important
Should
that people into
yes, yes.
is working.
Yes.
There are a
So
lot of
everything start.
DBase, cherry pick.
Yes. Yes. Start with using Linux.
May not be entire Linux. Linux is
Sorry.
may not be entire Linux, but Linux
Yes.
command and shell commands is yes very important.
Yes. Or we even can put it like not using the GUI and
Yeah, right.
Command prompts.
yes,
So Linux is will play major or important role in that, right?
yes. So mostly nowadays your infrastructure is in Linux environment. So for that, Linux is important. So some companies also use Windows based, but that is on a really rare side.
Uh, uh, Prashant sir, not on DevOps but other things related to Jira. So do we have any colleagues or folks in our community where they have presented POCs on SDLC software development lifecycle GenAI based on GenAI.
Yeah, we can talk about that. Shall we stop this recording for now?
Yes, yes.
Yeah. So before we stop, Alankar sir, thank you so much.
Thank
Uh,
you, Alankar sir.
Good mentor.
Yeah, thank you.
Uh,
Thank you.
yeah. And thank you for all the questions, Sachin sir, Swapnil sir. Thank you.
I have one more for you.